I'm going to show how to recrystallize a solid product, and for this video I'll be using the product formed in the photochemical isomerization lab. So this is cis-1,2-dibenzoyl ethylene. So you'll want to transfer your crude product over to either a test tube or a Craig tube, depending on how you plan on separating the crystals from the solution once the recrystallization process is done. And you'll want to use one of these tubes because they are made to withstand more drastic temperature changes without cracking, whereas if you use a beaker or a conical vial, those could break upon transferring them from the hot water bath over to the ice bath. Once the product is in there though, you can place the test tube or the Craig tube into the hot water bath and start getting the solvent that you'll be using to dissolve the solid. In this example, I'll be following the procedure and using 95% ethanol as the recrystallization solvent. And you can do the same. You should follow the procedure in any given lab, dissolving the solid product in whatever solvent it recommends. The general idea with this technique though is to use a solvent which fairly readily dissolves the solid product at higher temperatures, like in a hot water bath, but the product should have a much lower solubility in that solvent at lower temperatures so that it can come out of solution. Using a Pasteur pipette, you can add some of that solvent to a separate test tube and place that into the hot water bath as well so that it's also at a higher temperature when you add it to the product. To make sure that everything remains at a steady hot temperature, the water should be boiling or even the solvent boiling, but at certain parts in this video it can be hard to see everything that's going on with the solvent boiling, so I may turn it down a little bit. Once the hot bath is ready, you can start slowly adding the solvent using a Pasteur pipette. This should be done slowly in order to not add an excessive amount of solvent where you would have problems getting the product to come out of solution even when you cooled it down. You should also stir the solution to help the product dissolve in a minimum amount of solvent, and you can do that by spinning the spatula in between your fingers. More solvent should be added until the product is completely dissolved in the solution. And there's not going to be a specific amount for every single lab because that'll depend on how much solid you had, how soluble that product is in the solvent, plus it could also depend on what temperature you have the hot water bath at. So you should continue to add the solvent in small increments while stirring the solution just up until the product is fully dissolved in that solution. And each time before adding more solvent, you should stir the solution really well to allow the solid to dissolve as much as possible, and if it's not fully dissolved at that point, then you can add more solvent. Once the solid is dissolved, you can take the test tube out of the hot water bath and transfer it over to an ice bath to test if the product can come out of that solution. You can stir the test tube in the ice bath to help it cool down, but if after a few minutes no solid crashes out of solution, then you've probably added too much solvent and should evaporate some off so that the product can come out. Here you can see some of the product coming out of solution at the bottom of the test tube, and if this happens slowly enough in an ice bath, it could produce pure and large crystals that would be perfect for characterizing. So it doesn't really matter what temperature you do this at, as long as the product recrystallizes slowly. Usually we do it at room temperature because that allows the product to come out of solution and recrystallize at a slow enough rate to form pure crystals, but it could also be done in an ice bath if it's slow enough. Now I've sped the end of this video up a bit, but it took about 2 minutes for the product to fully come out of solution, and if I hadn't stirred it in the ice bath, it's possible that it would have recrystallized slow enough, but I want to try leaving it out at room temperature to see if I can get an even slower recrystallization. To let it recrystallize at room temperature, you want to redissolve the solid so you can take it out of the ice bath and put it back into the hot water bath. Then stir the product until it's once again fully dissolved into the solution. You shouldn't have to add any more solvent at this point because the conditions should be the same. So once the product is dissolved again, you can remove the test tube from the hot water bath and place it in a test tube rack to let it sit at room temperature. This portion is sped up to 8 times the normal speed because the actual recrystallization took between 8 and 10 minutes to finish. But you can start to see that the crystals are forming at the bottom of the test tube, And this time they're forming a lot slower than they did in the ice bath, so we should see larger crystals. Once it appears that no more crystals are forming, then the recrystallization process is done, and you can then remove the crystals by either using vacuum filtration, or if you use a Craig tube, then you can use a stopper and place it into a centrifuge.